many network engineers struggle with regular expressions. Now, regular expressions are very, very powerful tool that can be used to match for patterns in a known or, let's say, unknown text. Now, when used in context of BGP, regular expressions are used to match against the AS path. Now, the AS path is basically just an ordered list of autonomous systems where the prefix was present. So if we take a look at the examples that we have been working on so far, this is the AS path. So now we are on R1, and we are seeing that route 192.168.0.9 has been in autonomous systems 2456 and 900. Now, when we take a look at this list, there are important things to remember. One, and this is again a very, very important thing that I'm going to mention, is that this I, which is the origin code, as we remember, is not part of the AS path. So the AS path list is basically just 2456 900. And another important thing to remember is that start of string is the end of the path, and the end of string is the start of the path. So in our case, where we had 2, 4, 5, 6, 900, this here is the end of string. This here is start of string. But this here is actually start of path. And this here is actually end of path. In other words, when we have a string, the AS path string, and let's say 2, 4, 5, 6, let's say that we had 900, and let's say that we had 850, 750, 17, 2000, or something like this. This here and this here are going to be regular expression markers that mark start of string and end of string. So caret indicates the beginning of the string, the dollar indicates the end of the string. All these empty spaces in between here can be identified with underscores, but underscore will actually match the caret and the dollar as well, just so you keep that in mind. But also, the important thing is that this one here, this autonomous system, is something that we are going to be calling the peer AS. This autonomous system is something that we will be calling the origin AS. So, important thing not to mix this up with the origin code. The origin code is not part of the path, so it is outside the path. So this is not the origin that I mean. The origin as in where in the in which autonomous system this prefix was actually injected into BGP. And all together these mark up the transit path. So this is the transit path that this prefix that has this AS path list has. Now, very, very often in the CCIE lab, when they talk about the transit autonomous systems, they talk about actually these autonomous systems here. So neither the origin nor the AS. But technically speaking, this is the entire transit path. So what in the lab you are very, very likely to be asked about is to filter autonomous system, filter prefixes based on either peer AS, origin AS, or transit AS. Now, the very simple cheat sheet here would be, if you want to filter based on the peer AS, this is your cheat sheet. If you want to peer based on the origin AS, this, and if you want to filter based on the transit AS, this would be the filter that you can use. Now, as I said, this is a very, very quick and dirty cheat sheet. Now, why do I call it the cheat sheet? Because I'm not actually explaining how the regular expressions work, but these are the most likely questions that you are going to be asked in the lab. Now, that said, regular expressions can be a lot more complicated. Now, to understand some of the complexity, and I'm not going to go very, very, very deep here, there are some special characters in regular expressions that can be used to create very, very special, very powerful regular expressions. Now, the first special character that I'm going to talk is a simple dot. This simply means any character. So dot will match any single character. Underscore will match start of line or start of string, end of string, or white space. If you have caret, it matches start of string. Dollar matches end of string. Now, question mark means previous pattern may or may not appear. Star means previous pattern may or may not appear, and repeat. Plus means that previous pattern must appear and may, or actually I should clarify this one here for the previous one, and it may or may not appear, may or may not repeat. And the plus means that the previous pattern must appear, so it must show up at least once, and may or may not repeat. Now, this brings me to the subject of what is a pattern. Now, the pattern by default is a single character, which means that, for example, 2, 4, 5, 6 is a string containing 4 patterns that are matched individually. So regular expressions don't understand this as 2456. The regular expressions understand this 2 immediately followed by 4, immediately followed by 5, immediately followed by 6. So if you wrote a regular expression that looks like 2, 4, 5, 6 question mark, this would match 2, 4, 5, 6 or 2, 4, 5. Why? Because the question mark here actually applies only to 6. So the pattern is a single character, but it can be a range of characters if you list them like this. So when you use brackets, this would match 0 or 1, or 2, or 3. So it matches the range from 0 to 3. Now, you can also write something like this. This matches 4, or 3, or 1, but again, just a single character. Or you can match group of characters. So you can use parentheses, for example, to say 1, 2, 3. Now, this will match, so the parentheses are the important bit here. This would be the equivalent of matching 1, 2, 3. So for example, when you use parentheses, you can say something like 1, 2, 3 space may or may not appear. So now this would match, for example, 4, 5, 6 followed by 7, 3, 1, or it would match 4, 5, 6 followed by 7, 3, 1 followed by 2, 3. Why? Because take a look at this. We do have 1, 2, 3 space that actually we are trying to match. So again, be aware that regular expressions are not number aware. They are aware of single digits, but they don't understand this as 73,123. The only thing that we are telling it is 1, 2, 3 followed by space, followed by a special character, either a white space or start of string or end of string. So that's what that does. So if you want to match numbers, then remember, what is a number when written in a string? It's a series of digits followed or surrounded by special characters. The special characters are either white space or beginning or the start of line. So if you actually want to match number 1, 2, 3, much better pattern to use would be underscore 1, 2, 3 underscore. Because this tells your router that you are looking only 1, 2, 3 standing as an individual group of characters, not immediately preceded by other digits or immediately followed by other digits. So these are the very, very basics of regular expressions. But this, in combination with these modifiers, with these special characters, and in combination with understanding what different terminology means here, is what will help you actually solve those requirements if you encounter them in the question here was, why does this pattern 1, 2, 3 matches 4, 3, 6 followed by 7, 3, 1? Now, it matches because of this question mark. Because the question mark here says this may or may not appear. So I'm saying in my pattern that, by the way, is this, 1, 2, 3 may or may not appear. Does it appear? It doesn't. We have still satisfied the requirements of the task. This is an optional pattern, but this question mark here applies to the whole group now. It doesn't apply to a single character. Because of the parentheses, this behavior modifier, as it's correctly called in regular expressions, actually applies to the whole group of characters. Now, if I had this as the regular pattern, if this was my match pattern, and this was the string that I was matching, this would have not been a match, because I'm telling it this must be found in the string. And in this case, it's not found. But when I use the question mark, I'm saying this appearance of this is entirely optional. Now, in this particular case, it makes no sense. But there are some situations when you have certain optional patterns that may or may not appear. Here is one thing. Let's say that you have two autonomous systems. Let's say that you have AS100 that is connected to AS200. Now, you need to filter traffic, or not traffic, you need to filter the routes coming in this direction here. Now, mind you, behind the AS200, I might have any number of other autonomous systems. Now, the task here says make sure that you allow the traffic coming in from AS200, and AS200 may be prepending, may be allowed to prepend. Okay, so how am I going to solve that particular task? So I can say something like, okay, I'm going to allow the routes that are coming from AS200, but how do I know if they are prepending? Okay, so let's do this. For example, so what I'm saying here is, now, allow AS200, so this is what takes care of that. But if they are prepending once, I'm going to allow that. But if they are not prepending, I'm still going to allow this traffic from coming in. Now, even better pattern in this case would have been something along these lines. Now, again, this bit here is strictly optional because we don't care what comes after this. So even better pattern would be something along these lines. Because we are saying, okay, 200 may appear multiple times in a row. I don't care about it. So maybe I should add the underscores here, even better. But you get the idea. So sometimes this question mark here makes sense. In some cases, like the example that I've given you here it's completely pointless pattern. But it's important to know that if you wrote it like this, you would actually match like this. So you could have made a mistake using this pattern here. But in this case, question mark is not a mistake. Actually, we want to allow it to prepend. Let's say that the task was allow AS200 to prepend only once. Well, this would be the solution. Going back to this example here, where I said that in the lab, you are most likely to be asked to filter based on peer AS origin or transit AS. Now, there is one more thing that they might ask you to do, and that is filter just own routes. Now, routes that are originated in the AS in which you are. Now, the routes that are originated in the AS in which you are will have no AS path. So here I am on R1. You remember our example with R1. So here is R1, and this is the locally generated route. Take a look at the AS path. It's empty. It's non-existent. Now, I highlighted an empty space, but it's actually, there is a space here, and then there is nothing, and then there is I. So it's an empty string. Now, how do you match an empty string with regular expressions? Well, think about it. What you need to have is beginning of the line immediately followed by the end of the line. So this will actually match your own routes. Now, they can also ask you a task, in a task, to match all the routes. Oops, that was a mistake. Just to match all the routes. Now, if you're asked to match all the routes using regular expressions, the task is very simple. Match any character that may or may not repeat. So it may or may not be there. So remember what that character modifier does. So previous pattern, any character, may or may not appear and may or may not repeat. So in a sense, this will match if an empty string, and it will match anything else. So this cheat sheet here, so let me write what this is. Is really a recipe book that you need to have with you when you go to the lab. Yes, it might happen, unlikely, that they ask you some of the more advanced questions here, so you need to know how these other regular expressions work, but in my experience, these are the most likely questions that you will be asked to answer in the lab when it comes to regular expressions. Are the regular expressions documented in any of the documents that are available to us in the lab? Well, first of all, let's see what is available to us in the lab. So let me just try to find that link. Here it is. So let me bring in my web browser. So the documentation that you will have available in the lab is basically this site here. I don't know if you can see it. So what I'm going to do is I'm just going to copy paste it for you. So this is what you will have available in the lab. Now, in the lab, as a general rule, anything that is accessible from these 3 panels here will be available to you. Anything else that you have on this page, especially the search function here, the find function, is not available, or it may or may not be available, so you cannot rely on it. So I don't know the answer to your question, but I know where to look if there is a question. So I'm going to go to Cisco iOS and NXOS software, going to go to Cisco iOS, going to click on 12.4 family, 12.4T, going to wait for this to load, and then going to go, need to scroll down. If I go to the configuration guide, so configuration guides here, and in the terminal services below, here in appendices, if I go here, I will have regular expressions, there we go, and we will have the list of all the regular expressions. So you can see here that we have quite a few of special characters, but I didn't really want to go through all of them, but they explain pretty much the same thing I mentioned. So you will have the reference. Just remember, it's in the configuration guide, in the terminal services configuration guide, not the command references.